Welcome to the sponsored exhibit for Hitachi ABB Power Grids. I am Abhishek Raj and I would like to welcome you all to this session. Bus technology has been rapidly evolving, but charging technology has evolved as well. This technology now ranges from overhead chargers to energy storage enabled depot chargers. To get more information about the latest development in these fields, we have today Alexander Lalonde from Hitachi ABB Power Grids to present about the latest developments in this field. So Alex has been a part of Hitachi ABB Power Grids group and is based out of Montreal, Quebec, Canada. He joined Hitachi ABB Power Grids in 2017. Back then it was still ABB, where he held various roles, including technical sales, business development, and local product management for North American market in the EV charging segment. Since August 2020, Alexander is leading the EV charging initiatives for Hitachi ABB Power Grids on the North American market. Alexander holds a Bachelor of Electrical Engineering degree from University de Sherbrooke with a concentration in Power Engineering from Institut Ingénieur de l'Énergie Électrique Polytechnique Montréal. With that, I would like to turn to you, Alex, and you have 10 minutes for your presentation. Thank you.
Thank you very much, Abhishek. So thank you everyone for joining this exhibitor session. I know those are very long days typically in virtual conferences, so appreciate you taking the time to join us this afternoon. The plan for me, we have about 10 minutes for a presentation. Hopefully I can take a bit less to open up the floor for your questions. I prepared just a quick slide here to introduce the Hitachi ABB offering. You may have listened to the panel where my colleague Daniel presented a little bit Hitachi's positioning on the EV charging market. I'm here more to dive into the charging technology and what we're offering on the Hitachi side. So first, just before diving into the solution itself, for those of you that may not have taken part of this panel where Daniel, I'm sure, covered this section very well. Just for those of you to understand the relationship with Hitachi and ABB, sometimes that can be confusing. So in 2020, what happened is the transaction where ABB divested its power grid business took place, and actually Hitachi decided to buy this division out of ABB, and that transaction created a temporary entity that we now call Hitachi ABB Power Grid, which is deemed to be a transition from the ABB Power Grids business towards the full Hitachi Power Grid. So it's a temporary entity. It's a joint venture with the majority share being from Hitachi with a bit more than 80%, and purely financial shares from ABB to really ease and smoothen the transition. Now, the Power Grids business is actually made out of 4 business lines, and the 4 businesses are the grid automation, the grid integration, the high voltage products, and transformers. So in a nutshell, all the power grids equipment that you may or perhaps may not have seen in the past, the big transformers and substations, are part of this transaction. So they are now part of the Hitachi. Moving forward, again, we will see this company become Hitachi Power Grid, which is going to be part of the energy division of Hitachi Global. So now talking about the more important stuff for today's presentation, really Hitachi is coming into the picture on the EV charging side as a solution provider. So we have been part of the overall energy world for the past 100 years, and we know very well what it means to develop energy systems. And also from our more recent, I would say, and more in the tens of past few years, we've been involved in the railway and bus electrification through our flash charging technologies, which are really made us understand more the challenges of operating electric fleets, and also transitioning from a ICE vehicles towards electric vehicles. So we're coming in for the fleet charging market with this solution mindset, where we know that large-scale adoption of the electric vehicle technologies will require larger systems. Electrifying fleets of buses. I'm sure I'm not, after all these days of this conference, I'm not learning you anything by saying, it reaches the megawatts level. So we know it takes a lot of technologies, both from the hardware and software, and this is what we're aiming here at providing. Now, what is this Grid Emotion Fleet? Grid Emotion Fleet is a trademark name of our charging or fleet charging technology. Grid Emotion Fleet is essentially an optimized charging solution for large-scale deployment. So it consists of a AC to DC, a common AC to DC rectification block that we see in the very middle of the chart here, which creates a common DC bus that we then share to DC-DC converters, which are stacked into these racks here. So really, one of the key element is the common DC power sharing within the cabinet. This is in order to avoid having to distribute all of this electricity across, a low voltage, a typical low voltage connection, which requires its whole lot of equipment, cabling, installation upstream. So we're really condensing everything, simplifying the overall system and the power conversion to enable a very optimized in terms of footprint, but optimized in terms of system as well, and scalable solution. So going into a little bit more in the details of each and every block of our solution, if you look at the center picture, you have the grid connection that goes into typically a medium voltage or low voltage switchgear. It then goes into our rectifier and rectifier transformer module, which are also taken from our past experience in the railway industry. So proven technology from that point, and then going into these DC-DC converters. What you need to really visualize is these DC-DC converters really act as individual chargers. So those are power blocks that we will configure, that we can configure and joining them together to reach higher power, or letting them alone to have multiple chargers in these single blocks. So you'll see in the next slide how we can configure them. Now, the last part of the system will be the charging interface, where there is a flexibility in that sense, where we can use cabling, we can use cable-based interfaces, or pantographs like it is the norm in the transit industry in North America. So this is really what sums up the Grid Emotion Fleet approach. Now, what are the benefits of that technology? It's fairly simple. I mean, major footprint reduction in terms of the overall system. So looking at the overall installation footprint, we're reaching up to 60% of reduction, which is really important. Now, there's also, by skipping through the whole typical low voltage distribution, we'll be saving a lot on the cabling, and the equipment that is required upstream. And nonetheless, the complexity, reducing the complexity of the system and using proven technology that has been used for the past, tens, if not hundreds of years to feed, one of the few first electric vehicles used at scale, which are the trains. We did definitely improve the availability. Now, last but not least, the ability for us, by using this rectifier transformer and rectifier module, is the ability to connect directly to medium voltage. So this is essential when it comes to electrifying large-scale fleets, and really that's what the Emotion solution provides. Now, looking at the overall system, we have, as you can see on the picture, our rectifier transformer, rectifier, DC-DC converter. So those are all modules that we can combine and recombine as we want to really tailor the overall system to the fleet and operational requirements. Each and every module, so we can create lineups like this, ranging up to 3 megawatts in terms of total system size, and combine different charging interfaces, from the pantograph to the more simple cable-based solutions. Now, since I said there's a whole charging and I would say infrastructure part. We also do and offer a fully integrated software solution, which is made out of modules that we either already use in other applications, such as our battery storage and renewable integrations, but also these new applications here with electric vehicles. So ranging from the ground up, we could look at the charger, integrating the charger, the overall grid connection, on-site generation, battery storage, and EV set points and data points into all of this of our software solution in order to create optimization and overall energy management for our depot, and also adding in more control and monitoring capabilities through our SCADA system. Also, going up into the cloud, it opens up the door to all big data optimization and also preventive maintenance and analytics that we can also provide through what we call our monitor platform. Those are all really fully integrated, and since it's a very modular approach, we have this pick and choose approach again that gives flexibility to our customer. So that's in a nutshell what Hitachi can provide in this space. I know time is running. I want to leave some time for questions. So I'll open up the floor here to any question you may have on the technology itself.
Thanks a lot, Alex. And I believe definitely that was a brief but really informative and insightful presentation. We definitely see that the charging industry has evolved a lot since our early days of eBus Phase 1 project. And my first question is basically focusing on that evolution that has taken place. So I'd like to know from you, like based on your experience, based on the various deployments that you have already made, how do you see the charging technology evolve so far, and like what have been the key learnings from those big demonstration projects that you have recently carried out?
I would say the one of the key learning is that there's no one size fits all. So really this approach, and you may have realized from the presentation that we're looking at a very modular approach where everything's going to be tailored, to the project specific requirements. And this is really essential, I think, for really electrifying at scale. Now, in terms of a real life experience that we in a project that we executed, and actually we are executing right now, is in Brisbane in Australia, where we're deploying this grid emotion fleet solution in conjunctions with our flash charging technology. And really one of the key requirement in that project was the footprint. So that really drove us into optimizing everything that we could to minimize the footprint, and ended up being the perfect solution for them with this approach. Also, I would say what has been a key driver in this project is the fact that the operator knew and was comfortable with the DC, the common DC bus approach, just because they knew this technology from past applications. So that really comforted them into the reliability and the long life expectancy of the technology.
Yep, that definitely sounds wonderful. And I'm waiting for more of those demonstration projects happening here in Canada and North America. The next question that we have from our audience here is David Grabowski has put forward a question asking the voltage of the DC common bus.
The voltage is 750 volts, so classic voltage as we see them in the subway and light rail applications. And although you covered it extensively in your slide, I will still ask a bit more from you here in terms of what more could be the benefits of this DC charging technology, and how it differentiates itself from others. Well, of course, the DC technology, even though it's not, I wouldn't say it's a common approach for the charging part. It's a technology that's been known for years and years, again, in the railway industry. So it opens up the door to a lot of different schemes in terms of adding redundancy in the system and deploying, systems at scale. So knowing that we have a common point of connection that can be at the medium voltage and low voltage, and then we have this block in the middle that we know will convert it from AC to DC, and then knowing that technology from the past and the redundancy strategies that we can put forward, this really opens up the door to, I mean, any idea that we could have, adding in redundancy, adding in more system optimization, sizing the different components as we may have them already in our system. So really, the flexibility is key, I would say, in here, and this is what we're offering overall.
Okay, yeah, thanks, Alex. So Alex, the next question that I have, it's kind of an extension, like we are continuously evolving technology, but I would still like to know, in terms of interoperability with the buses, have we reached the junction of 100% interoperability, or is there still some road to be traveled before we reach that particular goal?
Of course, that's a very, very important topic and question. So right now we are working on deployments in North America, which involves its own lot of interoperability testing, but we're pushing it even further by actually, I would say, let's just say we're pushing the interoperability of doing it before we're engaging into a project. So this is what we're working on right now. We're doing it at the moment with our European colleagues and European OEM, and we're planning to start doing it very soon in North America for the North American market and OEMs. So this is something that we treat extremely importantly, and we know it's a key driver for us here.
Definitely, and I think maybe I would borrow something from Daniel's presentation earlier, and Daniel clearly highlighted that some of the steps that we could take to ensure higher interoperability could be like developing test centers, so that before the final equipment is delivered to the transit agencies, both the bus manufacturers and the charger manufacturers could actually test it out at a common facility or somewhere. So I think that is definitely very insightful. The next question that I have here from the audience here is, in terms of the skill set required, do we still have adequate technician staff equipped with the new skills that are required for the evolving charger technology, or we are still finding some skill gaps here?
All the technology that we're deploying here are known technology. I mean, there's no rocket science in here. It's really a matter of getting the technicians trained to operate and maintain these systems. From an operation perspective, it's no different from a standard charger. And from the maintenance perspective, everything is rack in, rack out. So there's no special skills involved in maintaining this system, other than having proper training from the OEMs on how the system interacts and how to maintain it. But nothing very specific. Perhaps on the medium voltage size, if you want to have a medium voltage connection, then we fall into the medium voltage classic, I would say, considerations. Other than that, it's pretty standard.
Interesting, yeah. So Alex, the next question that I have is basically from the grid emotion, the grid emotion slides that you highlighted in there. So my question here is with respect to the energy storage requirements. As we go, or as transit agencies scale up their fleet, we would be crossing that higher energy marks, and then it at one particular threshold starts to make sense to have energy storage integrated. I wanted to know how does the e-motion system that you highlighted it works with the energy storage requirements? Does it completely negate the requirement for energy storage, or does it still mitigates the peak demand for the power?
It's all a question of energy management. So peak shaving and the demand management in that respect is something that we offer through our energy management and optimization tools. However, we know that in certain cases it's not enough, right, to minimize the peak to the requirements and meet the requirements. And this is where sometimes battery energy storage can come into play. And right now it's completely embedded. We're using the same control software to run the energy optimization than we use in our microgrid applications, where we're taking into account the weather outside, the trigger points from the utilities, and also, I guess, all the energy that's being consumed on site, both from the building, from the operations themselves, being in our case here, charging of electric vehicles. So we're considering all of these set points into our energy management. And if we need, we also have the battery buffers, I could call them, to cover the rest. But really, those are, again, in our modular approach, what we would consider adding into the system to meet the requirements.
So thanks a lot, Alex, for that wonderful presentation and all those insights that you highlighted in here. So I'd just like to inform my audience that we are now starting our networking sessions. So if you have any further questions for Alex, I would advise you to get hold of him at that networking sessions. And I hope you enjoy the remaining sessions for the conference as well.